Hello everyone! So we are now down to the second part of our sixth lesson, which is the inverse Laplace transform here in Advanced Engineering Mathematics for Civil Engineers. So for the intended learning outcome for this lesson, so this will be the same learning outcome no, from our previous recorded video discussion. So students must be able to transform frequency domain functions to time domain functions. So let's start the discussion now. So let's discuss now the inverse Laplace transform of an integral. Okay, so if the inverse Laplace transform of a Laplace transform is equal to f of t, then the inverse Laplace transform of 1 over s times f of s equal to integral of fu du from 0 to t, wherein fu here, this is the inverse Laplace transform of f of s of this f of s, okay, expressed in u. Okay, if we can factor out 1 over s no from the given f of s, okay, if we can factor that out no this 1 over s, automatically we can write this inverse Laplace transform into this no. So this is the equivalent of this. Okay, so if you have, let's say if you have a given f of s. Okay, you have a given f of s and you can factor out 1 over s from this f of s, and you can if you can express it as 1 over s times f of s, no, so automatically we will use this. Okay, we will use this equivalent, no, wherein this f of u, this is the inverse Laplace transform of this f of s. Okay, so this f of s, no, so we this is already an f of s wherein 1 over s was already factored out. Okay, so we will solve for that. And then the limits here are from 0 to t. So the final answer for this will be in terms of t, no, which will be f of t, which is this is the inverse Laplace transform that we want to solve from this. Okay, so let's try solving problems for this. Okay, find the inverse Laplace transform of the following. So this is the given f of s. This is equal to 1 over s squared plus s. Okay, so for our solution here, no, so we will analyze the given f of s. Can we factor out 1 over s from this given Laplace transform, no? So we can actually factor out, right? Factor out 1 over s from here. Okay, so this will just be equivalent, right? 1 over s times 1 over s plus 1. This is just the same from here, no? So if we distribute this s, no, to the denominator, this will just become s times s squared, and then s times 1, that will be s, no, which is equivalent to this. So if we already factored out 1 over s from 1 over s squared plus s, no, so this will be the new form, no, of our given. Okay, so we cannot do this if we are going to solve for the f of t or the inverse Laplace transform of this. We cannot just solve for the inverse Laplace transform of 1 over s, okay, and then multiply it by the inverse Laplace transform of 1 over s plus 1. So we cannot do that. Okay, so instead we are going to use the inverse Laplace transform of an integral, no. So we will use this, no. So since we already factored out 1 over s, no, from the original given f of s, no, so it will be rewritten this way. So what we're going to do here is that we can equate this, no, or rewrite this to this. Okay, so this is just equivalent to this. So what we're going to do here is write integral of f of u. So our f of u is this is the inverse Laplace transform of this f of s. Now, in this case, our f of s here is 1 over s plus 1. Okay, so we will solve for its inverse Laplace transform, no, expressed in u, and we will integrate this with respect to u. So the inverse Laplace transform of 1 over s plus 1, okay, so that is actually e raised to negative u, right? Our a here, no. So in this case, no, this is supposed to be e raised to at, no, but instead of t we will use u. How we will express the inverse Laplace transform of this in u. Okay, so this will be e raised to au, no, wherein our a here is -1, right? So it will become e raised to negative u. Now, so we will integrate this, no, with respect to u. So integrating this will just become negative e raised to negative u, and we will evaluate this from 0 to t. So we will substitute the upper and lower limit to variable u. Yeah, to the variable u, no, and then we're going to evaluate this. So we can factor out negative here, okay, and then e raised to negative u, so substitute first the upper limit, which is t, minus e raised to negative u ulit, and then substitute the lower limit, which is 0. Okay, so evaluating this, simplifying this, so this will just become negative e raised to negative t plus 1. So this will now be the answer for this. Okay, so, okay. Okay, so for sample problem number 2, we will find the inverse Laplace transform of the given f of s here. So the given f of s here is 1 over s to the fourth plus s squared. No? So as you can see, in this given f of s, we can actually factor out 1 over s squared, no, from here. Okay, so factoring out 1 over s squared, no, so this will become 1 over s squared times 1 over s squared plus 1. Right, so this is just equivalent, no, if we distribute s squared to the denominator s squared plus 1. So this will just be ano, equivalent to this, s to the fourth plus s squared, right? Okay, so if you're thinking of solving the inverse Laplace transform of this by just solving the Laplace transform of 1 over s squared and then multiply it by the inverse Laplace transform of 1 over s squared plus 1, so this is wrong. Okay, so this is wrong. So we are going to apply the inverse Laplace transform of the Laplace transform of an integral for this, no? So we can rewrite this given, no? So this is the given. So we can rewrite this as 1 over s times 1 over s times 1 over s squared plus 1. Okay, so we are going to apply this. So we can only apply this if we can factor out 1 over s from the given f of s. So in this case, we factored out 1 over s here. Okay, so if this is 1 over s, no, so this 1 over s times 1 over s squared plus 1, this will serve as this f of s. No, so we can rewrite this, okay, into this, okay, into integral, no? Okay, so rewriting this, no, so for our f of t, that will be the inverse Laplace transform of this, okay, and the inverse Laplace transform of this, okay, is equivalent to this, okay, wherein f of u here, this is the inverse Laplace transform of this f of s expressed in u. So in this case, our f of s here, okay, is 1 over s times 1 over s squared plus 1. Okay, so we are going to simplify this, no? So for this, no, actually here, if we rewrite it, no, from integral of the inverse Laplace transform of 1 over s times 1 over s squared plus 1 du from 0 to t. So if you are going to solve for the inverse Laplace transform of this, okay, so this is actually inverse Laplace transform of 1 over s times 1 over s squared plus 1. So in this case, there's also a factored 1 over s here, right? So meaning to say, we will apply this again the second time around. Okay, so we will apply this, no, the second time. So we can rewrite the inverse Laplace transform of 1 over s times 1 over s squared plus 1 as integral of the inverse Laplace transform of 1 over s squared plus 1 du from 0 to t. Okay, so we're going to rewrite it this way, no? So this will be the equivalent of this, the inverse Laplace transform of 1 over s times 1 over s squared plus 1. So this can be rewritten this way. So solving this, no, so we will solve first this term, no, inside this brace, no. So for this, no, so the inverse Laplace transform of 1 over s squared plus 1 expressed in u, that is actually sine u. Right? So this is 1 over s squared plus 1. So this is sine u, sine 1, actually sine t, right? But we will, instead of expressing it in terms of t, we will express it in terms of u, no? So we're going to solve now this, no, the integral of sine u du from 0 to t. Okay, so integrating that, that is actually negative cosine u from 0 to t. So we will evaluate this from 0 to t. So substituting the upper limit to variable u. So this will become cosine t, no? So we just factor out negative here. Minus cosine, we substitute the lower limit, which is 0 to variable u. So that will be cosine 0. So simplifying this, no? So this will become negative cosine t plus cosine of 0. The cosine of 0 is 1. Okay, so this will become negative cosine t plus 1. Right? But in this case, no, we have to express again that variable t into u. No? So instead of negative cosine t plus 1, so we will rewrite it as negative cosine u plus 1. Okay? And now we are going to integrate this negative cosine u plus 1 du from 0 to t. So integrating this, so the integral of negative cosine u du, that is negative sine u. And then the derivative, integral rather, and then the integral of 1 du, so that is u. Okay, and we will evaluate this from 0 to t. Okay, so evaluating this from 0 to t, okay, so we are going to substitute t, no, to the variables u here. So this will become negative sine t plus t minus, we now substitute the lower limit, which is 0 to all the variables u. So this will become negative sine of 0 plus 0. So as we know, the sine of 0 is actually 0. Okay, so simplifying this, so this will just become negative sine t plus t. So this will now be the answer for this. Now let's proceed to convolution. If f of t and g of t are inverse transforms of f of s and g of s, then the inverse Laplace transforms h of t of the product h of s equal to f of s gs is the convolution of f of t and g of t and is defined by h of t is equal to integral of f of x, okay, times g of t minus x dx from 0 to t. So we will use convolution. Okay, if we can rewrite, no, if we can rewrite the given f of s into its into factored form. Okay, and then what we're going to do there, we are going to assign one of the functions, no, one of the given functions as to f of t and g of t, wherein f of t and g of t, they are the inverse Laplace transform of those factors, no, respectively. And then what we're going to do is express f of t as f of x, okay, and we will express g of t as g of t minus x, and we will just substitute those equivalents, no, to this formula, and then we will integrate this with respect to x, and we will have this limit from 0 to t. So that will now be the inverse Laplace transform of that given Laplace transform. Okay, so let's try solving problems for this. Okay, so find the inverse Laplace transform of the following using convolution. Okay, so the given f of s here is 1 over s squared plus s. So we can use convolution if we can rewrite the given f of s into its factored form. So in this case, its factored form is actually it's actually 1 over s times 1 over s plus 1. So this is the factored form of this. Right now, if you are going to apply convolution, what we're going to do, okay, is assign functions, no? We will separate 1 over s and 1 over s plus 1. So we can assign either of these two to g of t and f of t, no? So it can be interchanged. So we can assign 1 over s to g of t, no? So what we're going to do here is solve for the inverse Laplace transform of 1 over s. No, so we will assign that here for g of t, and then for f of t, we will assign the remaining function, which is 1 over s plus 1. Okay, so that will be the inverse Laplace transform of 1 over s plus 1. That's what we need here. Okay, so solving for the inverse Laplace transform of 1 over s, that is actually 1. So this will now be the value of g of t. Now, for the inverse Laplace transform of 1 over s plus 1, this is actually e raised to negative t. Okay, so this will now be the f of t. Now, we are going to express g of t as g of t minus x. So, meaning to say, this function, okay, so this function, if this is variable t, no, so we will replace all the variables t with t minus x. But in this case, no, our function here is just constant. So there is no variable t. So it will just remain. No, it will just be 1, no, here, no, since there is no variable t for this, no. So the g of t minus x will just be 1. Okay, now for f of t, we will express it as f of x. So all the variables t in this function, no, we will replace by x. No, so in this case, it will become e raised to negative x. Now, this g of t minus x and f of x, we will substitute this to our formula. So this is our formula for convolution. So we will substitute f of x here, this value, and for g of t minus x, we will substitute this this function. Okay, so let's start. Okay, so substituting the values of f of x and g of t minus x here, so this will become e raised to negative x times 1 dx. So we can actually integrate this already with respect to x, no? So this will just be e raised to negative x naman, no? Integral of e raised to negative x. So the integral of that will just be negative e raised to negative x. So we will evaluate this from 0 to t. Okay, so evaluating this from 0 to t, it will just become negative. We factor it out, and then we substitute the upper limit first, not to the variable x. So this will be e raised to negative t minus, we now substitute the lower limit to variable x. So this will become e raised to 0. No? So in this case, this will become negative e raised to negative t, and then the value of e raised to 0 is actually 1 times negative, so that will be positive. So this will now be the answer. So this is actually the same answer when you use the first method that we discussed here, no, from the first topic for this recorded discussion. No? So this is the same. So you either use this this method, no, this convolution. You can also use the previous topic, no. So it's up to you. Okay. Okay, so there is actually a solution to, no, using convolution. So for g of t, we are going to assign the 1 over s plus 1, no, the inverse Laplace transform of that. And for f of t, we can assign the inverse Laplace transform of 1 over s. Okay, so solving for this, so the inverse Laplace transform of 1 over s plus 1 is e raised to negative t. And then expressing g of t as g of t minus x. So in this case, we are going to replace all the variables t here, no, with t minus x. So this will become e raised to negative quantity t minus x. Okay, and here, the inverse Laplace transform of 1 over s is actually 1. So its f of x will just be equal to 1. So we are going to substitute these values, no, to the formula. So this will become integral of 1 times e raised to negative times t minus x dx from 0 to t. Okay, so integrating this. Now, so this is actually e raised to negative t minus x. So we will evaluate this from 0 to t. Okay, so evaluating this from 0 to t, we are going to replace or substitute the upper limit first, no, to all the variables x. So this will become e raised to negative times t minus t. Okay, minus, we substitute the lower limit, which is 0, to variable x. So this will be e raised to negative t minus 0. So simplifying this, so this will become e raised to 0 minus e raised to negative t. No? So e raised to 0 is just 1, and then minus e raised to negative t. So this is also the same answer, no, as solution 1. Okay, so you can either use this or solution 1. Okay, now for sample problem number 2, we are going to solve for the inverse Laplace transform of the given f of s using convolution. So in order for us to be able to use convolution, we have to factor or rewrite the given f of s into its equivalent factored form. No, so we can rewrite it this way. So this is the factored form of this. So this is 1 over s squared times 1 over s squared plus 1. No, so what we're going to do here to apply convolution, we will assign or we will separate 1 over s squared and 1 over s squared plus 1 and assign them to g of t and f of t. So any of this any of this term, no, can be assigned to g of t, or f of t, no? So in this case, let's just assign 1 over s squared to g of t. So we are going to solve for the inverse Laplace transform of 1 over s squared. And for f of t, we will assign the remaining function here, which is 1 over s squared plus 1. So this will be equal to the inverse Laplace transform of 1 over s squared plus 1. Okay, so solving for the inverse Laplace transform of 1 over s squared, that is actually t. And then for the inverse Laplace transform of 1 over s squared plus 1, that is actually sine t. Okay, so what we're going to do here is express g of t as g of t minus x. So all the variable t here will be replaced by t minus x, no? So this will become t minus x. And then for f of t, okay, so we will express f of t as f of x. So all the variables t here we will replace as x. Now, so this will become sine x. Now we will just substitute this g of t minus x and f of x to our formula. Okay, so substituting f of x, which is sine x, and g of t minus x, which is t minus x dx. So to solve this, now we will use integration by parts. So since this is a combination of a trigonometric function and algebraic function. So using IBP, we will assign function for u and for dv. Okay, so for u, what we're going to assign here, okay, is the function, no, that comes first in the acronym LIATE. So in this case, the function that comes first is algebraic, no, before exponential, no. So we will assign t minus x to u, and then we will assign the remaining function to dv together with dx. Okay, so our dv is sine x dx. So what we're going to do here for u, we will differentiate both sides. So this will become du is equal to negative dx. And for dv is equal to sine x dx, we will integrate both sides. So if we integrate both sides, the integral symbol and d will be cancelled. So what will remain is just v. And the integral of sine x dx is actually negative cosine x. So using IBP, so that is uv minus integral of v du, right? So for u, so t minus x, v negative cosine x from 0 to t minus integral of v. Our v is negative cosine x, our du is negative dx. So simplifying this, so this will just become negative cosine x times t minus x. We can evaluate this from 0 to t minus integral of, so this will become ano, no, negative times negative, it will be positive here, no, but this is negative still here, no. So this will become cosine x dx. So integrating cosine x dx, that is actually sine x, right? But since there is a negative here, this will become minus sine x, and we will evaluate this from 0 to t. So evaluating this from 0 to t, okay, so for this term, okay, so this is cosine x times t minus x. We substitute first, here the upper limit. So there is there is a negative here. No, so there is a negative here. Okay, so we just factor out that negative sign here, no, and then substituting the upper limit to all the variables x. So this will become cosine t times t minus t. Minus, we substitute the lower limit, which is 0. So this will become cosine 0 times t minus 0. Minus, for this one, we factor out this negative, no? And we will now substitute the upper limit to variable x, which it will become sine t minus, we now substitute the lower limit, which is 0. So this will become minus sine of 0. Okay, so simplifying this, so this will become t minus t will be 0. So this will now become 0. And then for this one, cosine of 0 is actually, cosine of 0, that is actually 1, right? Cosine of 0, that is 1. So cosine of 0 is actually 1. So 1, negative 1 times negative, that will become positive, times t. We still have t here, so that will just be t. No? Okay, minus sine t minus sine 0. So the sine of 0 is actually 0. Right? So what will remain here is just negative sine t. So this will now be the answer for this. The inverse Laplace transform of this given f of s is t minus sine t. This is already the answer. So that concludes our discussion for this topic. I hope that you learn and attain the learning outcomes. So this is actually our last discussion for this course, for this term. Okay, so I hope that you learn from me, no, in the entirety, okay, of this course, no, for this term. Okay, so would you please do me a favor? Would you please comment down in the comment section everything that you learn, no, from this course, no? So not just academically, okay, but in life, no, in general. Okay, so comment down in the comment section. So I'd be glad to hear from you, no? So I hope to see you soon, class, and I hope that it will be a different subject. Okay, so God bless you, class. Keep safe and see you soon, engineers. Bye-bye.